If I want to share data as an organization, I send it to my users. It's either in JSON or PDF format, for instance. So now those users can forward it digitally, or they could even print that information. In many cases, we also hand the data to processes where they're automatically being processed. Or in other cases, we're also leveraging blockchains to share the data. However, if somebody now receives that information, he doesn't know if it's still true. So he has to trust on the one hand in operations. On the other hand, he has to trust the data entry itself. And here also blockchain doesn't make the massive difference because we still need to trust the operations. Yes, we can participate in the operations, but for that we need the skills and resources. Therefore, of course, we have digital signatures, which we can leverage to sign the data, and by that add validation info to the metadata of our information. For this, the recipient can verify that the data is unchanged and doesn't have to trust the operations that much anymore because it's still the same format as the original sender had it. So we can ensure that the signature can ensure for us that we have data integrity. And through QR codes, we can also enable digital processes. However, we always need a digital identity in order to be sure that the data is also authentic, so that the true owner has published that data. The problem which we have with that, however, is that all the data or those keys have a predetermined validity. So the only way, in case we need to correct data or something went wrong, we can devalidate the key. But it also means we devalidate the key publicly, and everything we've ever signed with that key is invalid. So we have no real controls about that. If a key is being stolen, we won't see that. So data manipulation, if somebody has our key, will only get noticed once we see the result within the data, or that's noticed, not the signature process itself. And of course, we have no proof of timing. So the author of the data is able to rewrite it as often as he wishes without us being able to verify when the data was created. With Crypta, we take the standard process and integrate the cryptographic notary, which on the one hand enables us to redact information while maintaining the validity of the original data set. Now, we don't need to devalidate the entire key, but as I said earlier, we sign the data also when we update or delete it. So, and we publish a summary of those signature activities decentrally at a trust anchor location. So now, if we want to devalidate data, we can do that for every single signature we've performed. And we can control the validity of our data after sharing, regardless if it was phygital or digital. Additionally, we're also receiving evidence of our signature history in case we're getting any disputes. And we can detect if somebody else is abusing our key, because now we have a local reference of our signature history and we have a published history. If there's a discrepancy between those two, we can proactively react and start revoking our data, which is being signed by somebody else. Through this, we also get a legal evidence for the data validity and the timing of our data, and we can enable automated data cleanup. One of the clues in here is that we're able to really consolidate the entire signature history within each single hash. This enables us to also publish this data or the fingerprints asynchronously. So on the one hand, we can publish it to authorities and trust service providers like TÜV, D-Trust, or even a governmental agency. But we can also asynchronously publish the same verification on permissioned blockchains like ID Union or even any local Hyperledger implementation. And if that's not enough to scale the trust, we can also go to public blockchains. And we can use all of those simultaneously without having to build the trust ourselves. So we adjust to exactly the needs of the user to establish that trust. And by this, we can control the level of decentralization.